Okay guys, welcome back. So in this video I'll be talking about another topic on frictional forces. Now it is about the same topic I'll be talking about, but more generalized or a more complex topic, right? So I'll take an object like this. I'll take the same object so it will be easy for you to understand, as I used in the last video. Alright? This object. This is mass 10 kilograms, so it will be 10 G. Right? So its net force will be also 10 G, which is 100 newtons if G is taken as 10 meters per square second. So R will be 100 newtons, and I'll take mu to be 0.3. Sorry, no, this is a constant, right? 0.3, this is a constant. There's no SI unit for this. And what I am asking is that if I put a force of say 40 newtons here, 40 newtons, this object will accelerate. So I want to find the acceleration of this object first. So there are actually two questions. So I'll solve the first question and then go to the second question and then tell you what is it and then solve that. So the applied force is 40 newtons. So this is a friction surface. So in the last video, we have to find the frictional force. So it is actually this way, frictional force. So you know that at the limiting occasion of the maximum, we have to calculate the maximum frictional force. So at the limiting occasion, you know that Ff is equal to mu r. So I have given mu equals 0.3, r equals 100. So this will be 30 newtons. Ff is 30 newtons. So the force this side is 30 newtons, right? Force this side is 30 newtons, the force this side is 40 newtons, so there will be a net force of 10 newtons in this direction. So if I put F equals ma, F equals ma to this side, right? So the net force will be 10 newtons. Mass of this object will be 10 kilograms, has been given as 10 kilograms, and the acceleration is a. So a is equal to 1 meters per square second, right? So that's the acceleration. So that we found in the last video as well. So the next question I am asking is what is the minimum weight that should be added to this object to oppose this motion or to keep this object from station. Now initial mass of this object is 10 kilograms and it has a weight of 10 G. So if I put some 40 Newton force, as I calculated here, I will have an acceleration of 1 meter per second. So what I am asking is that to make acceleration 0, what is the minimum force to be applied? Now you know that Ff is equal to mu r, right? Ff is equal to mu r. You cannot change the value of mu for this surface. So this is like a box, right? This is like a box. So the friction acts between the box and this flow, right? The friction acts between the box and the flow, right? Now if this is an open-ended box, if I put some sand or some other stuff, some weight stuff here, this object's mass will increase, but still the two surfaces will be between the box and the flow, right? So the frictional coefficient will not change, so mu won't change. So for this object to make this object has a net force in this direction, so it has a net acceleration in this direction. So to make this object stationary, what I have to simply take is that if this force is 40 newtons, keeping this force constant, if I were to keep this object or make this object stationary without preventing it from moving, what I actually want is that I have to simply put a force of 40 newtons, force of greater than 40. So if the force is greater than 40, this object will not move. If the force is equal to 40, this object will be in the limiting occasion, right? So the minimum force needed to stop this object is 40 newtons. So I know that F equals mu r, F equals mu r, right? Ff equals mu r. So mu is a constant, so the minimum friction, right? So this is minimum frictional force is equal to mu times, mu is a constant, so you can take a minimum there, r minimum. So r equals mg, right? R equals mg, so Ff equals mu times mg minimum, right? So g is a constant, mu is a constant, you can take g out here as well. So ff min is equal to mu g times m minimum, right? So this is another derivation, right? M minimum. I don't. You don't need to remember this. This is just for the sum. M minimum. So what if you were to increase the frictional force? Now say this object, like in this location, the object has some force 40 newtons in this direction and 30 newton for frictional force in this direction, and this object accelerates at 1 meters per square second. So if you were to stop this object, keeping the applied force constant, not decreasing the applied force, keeping this applied force constant, what you need to do simply is you have to increase the frictional force. Now if this, as I mentioned, if the same object have been taken, the same surface, now this surface and this surface will be a constant, right? These two surfaces will be a constant, so mu is constant, g is constant. So what you can do to simply stop this object is you can increase its mass. So what I am asking is that what is the minimum mass that is needed, right, to be added to this system for making this object stationary or without preventing it from moving. Alright. So if min is equal to mu g min, so what is the minimum condition? Minimum condition is that to object to stop moving is that if applied is equal to ff or ff minimum. Minimum frictional force that is applied to this object should be equal to the applied force on actual applied force by me to this object. So F applied equals ff min. So what actually happens is that this force has been given as 40. This should be equal to mu times, I have taken here as mu g minimum, mu times g times a minimum. So that's just a direct substitution, right? 40 equals mu g. So 40 equals mu equals 0.3, g I have taken as 10 and a minimum. So this will be 3, right? 3. So a minimum will be 40 by 3. 40 by 3 is 13.33. 13.33 kilograms. So this is the total mass, right? I am not asking about the total mass. I am asking is what is the minimum mass that should be added. So I have already a mass of 10 kilograms for this object. So the minimum mass that should be added is m added should be equal to m present. Sorry, m minimum minus m present. Right? M minimum minus m present. Right? I have already some mass in this object. I want to make it to the m minimum to stop this object. So what is the mass? So this will be 13.33 is the minimum mass that should be added, and I have already added 10 kilograms. So the minimum mass, so the mass that should be added is 3.33 kilograms. 3.3 kilograms. 3.333 kilograms. So that is the minimum mass that should be added. So that's just another simple calculation based on the forces of friction. So see you in the next video with another concept.